Alright guys, so here's where we left off. We have a fully functioning game of Pong, and we've corrected all the issues that we had before. So today we're going to have a little bit of fun. We're going to add some interesting elements to the game to make it more challenging. So there's three things that we want to add. One, we want to make the ball go a little faster after every time the player hits it. Two, we want to add a bunch of balls. And three, we want to get the walls to cave in every time someone scores. So this will be a little bit of fun. I think this video is going to be a little more advanced than the previous two, so be ready for it and feel free to comment questions in the comments. Alright, so let's get started. So first thing we have to do is we want to make the ball go faster every time a player hits it. Luckily, because of this collision handler, we already have a function that occurs, method actually, that occurs every single time the ball hits the player, so we could just use that. And of course, the function I'm talking about is standardized velocity, and that's going to be in the ball class. The reason we did this, remember, is because we have a kinematic body, which is the players, and a dynamic body, which is the ball, and we don't want to pass momentum along to the ball. So the best way to do this is instead of standardizing to 750, we should standardize to a value that's changing every time. So I'm going to make this a attribute of the ball class called velocity. And we would set that to start in the init method at the 750 we had, and then every single time we standardize, we can increment this self.velocity. Let's increment by 50, so plus equals 50. So let's try this. Unfortunately, I'm not good at my own game. Okay, here we go. So yeah, the ball is going to be accelerating every single time I hit it, and this is starting to get kind of hard. But there you go. So we finished the first task. So I'll cross this out. Now let's make many balls instead of one. And this is going to be a little bit tricky. The key here is in our game loop, we want every time we do anything with the ball, we want to make that instead of a ball object, we want to make that a list of ball objects. So that includes the ball object itself. So we'll call this balls, and we'll say a list of them. So currently this list only has one element, but we will add on to it. And we also have to do this for all of the collision handling that the ball takes a part of. So scored 1 is going to be a list scored 1. Scored 2 is a list. Oop. And of course that's going to make this obsolete, but we'll come back to that. And we want to make contact with player a list. Now let's figure out what do we want to do with these functions. Now remember, these functions are passed to the collision handler and are meant to run whenever the collision handler activates. The problem is we have multiple balls now, or we have a list of balls now. So right down here, we want to say ball.standardized velocity, but the question becomes, well, which ball are we going to standardize the velocity for? Well, we'll say the 0th ball for now, but this is of course going to change when we add more balls. But right now we only have one, so we can say the 0th ball. And we'll do the same up here for when the ball scores. So balls of 0. So right now we really didn't change anything besides the fact that instead of having a ball object, we have a list of ball objects with just one element. And wherever we use this balls list, we've made sure that we're only referring to the 0th object. So if there's only one ball in this list, this is going to work just fine. So let's run this. Oh, I lied. Okay, so that's going to be scored 0 because now even the collision handlers are lists of collision handlers, and right now we want to just mess with the first one. Well, contact with player is also now a list. The last thing we have to change is scrolling down in our code. We say balls.draw. Well, we want to draw all of the balls. So to do that, we'll use list comprehension again. So we'll say ball.draw for ball in balls. So now let's run this. There we go. So nothing's changed. Instead of having one ball, we have a list of balls, but we only have one in the list currently. So we're gonna have to change that. So I think it'd be fun to add a ball every time we press this space bar, right? So to do that, we could do it in one of two ways, like we talked about before. We can use this sort of keys, pygame.key.press method, but this is usually used for either simultaneous keys or as if you're holding down the keys. Otherwise, you want to use the event loop. So a reminder of what the event loop does is it circles through all of the Pygame events, which include keyboard clicks and mouse button clicks. So let's go ahead and do that. So we're circling through all the events, and the relevant event is if event.type. So if the relevant event has an attribute of type, which holds the value pygame.keyDown, and event.key, which it only has this event.key attribute if the event.type equals pygame.keyDown, equals the key that we want, which is going to be pygame.k for key underscore space. So if the space bar is pressed, then this happens. So what do we want to put in here? Well, we want to add a ball. So I'll say balls dot append, because balls is now a list, ball. So we're going to append a new instance of the ball. Now we're going to have to do that for all of the collision handlers as well, right? So I can say scored one dot append. So what do I want to append? Well, I want to append another instance of this collision handler. Okay, and we're going to do the same thing for score 2. So if player 2 scores, space.add collision handler 1102. And we're going to want to do the same thing with contact with player. So I'm getting kind of lazy, so we're going to try using as much copy and paste as I can here. Dot append. Although we've added these collision handlers do not have an associated begin or post solve or whatever we want. So we're going to have to add that to them too. To do that, we can say, and we'll keep this along with its collision handler. So dot begin. And what is the function we want to run here? Well, and I should specify which index I want to run this at. I want to run this at the one I just added, so the last one in the list, which I can do in Python with the -1 index. What method or function do I want to send to the begin attribute? It's going to be player1 scored. And what do we want to do for score 2? Well, scored 2, the last one, the one we just appended, dot begin equals player 2 scored. And for contact with player, you can say contact with player, the one we just did, dot, I think we need post solve here. So similar to what we did up here, equals balls of the last one, the one we just put in, dot standardize. Okay, standardize velocity, there we go. Okay, so let's run this and see where our errors are. Well, there aren't, and everything seems to be okay. I'm gonna press the spacebar, and okay. Let's see what's happening here. So if I score with any of the balls, it's resetting all of the balls. Luckily, our spacebar function is working, but that isn't the behavior that we're looking for. So let's understand why that's happening. We want to recognize that when a player scores, the 0th ball is the only one being reset. So actually, it's not every ball that's being reset, just the 0th one. We don't want that. We want a certain index that's being reset. And the index that we want to be reset is the one that correlates index-wise to the list that contains the collision handler. Now you may be wondering, well, how am I going to pass anything to this function? Any arguments to this function? Well, that's where we can understand the space arbiter data mandatory parameters we need for any collision handler. So space is going to be obviously the space that we add the collision handler to. Arbiter happens behind the scenes. You guys can look at the documentation and understand where that comes from. But data is actually for us. So this parameter is used to pass any data we want through to this function. So I can say data here. And now as long as I know how to pass a value to this function, then it will show up here in this data variable. So let's do that. So instead of just resetting the 0th ball, we're going to reset this data variable ball. And we'll set the data variable to be the relevant one for the collision handler. So to do that, there's an attribute to the collision handler itself called data, which passes that data into the collision function. So let's go ahead and do that. So we'll do that for scored one. So scored one dot data. So what do we want to pass? We want to pass the index of the ball, of the last ball. So I guess the best way to do that is length of balls minus 1. Right, so let's kind of go through this again in our head. Let's say we're going to add our second ball, right? So balls out of pen, ball. The first time we're doing this, first time we press the spacebar, we have now 2 balls. But the second one has an index of 1, right? Because Python is 0 indexing. So length of balls minus 1 will be 1, the number 1, which is the data we want to pass to this collision handler. So this works. Now, instead of having to run the len function a bunch of times, I think it'd be cool just to say index up here. Say, this would be a problem. After we add the ball in, or we can just say length of balls without the minus 1, but I think this makes a little more intuitive sense. Index, and then we'll do this for all of these. So score 2 requires this as well. So let's try to run this. And list object has no attribute data. Okay, well, we're gonna need to pass this to not the whole list of collision handlers, but the last one that we just added. Sorry about that. And now let's run this. And list indices must be integers or slices, not none type. So yeah, we need to do this for the first one as well. So we gotta say scored one.data equals 0, because we want to pass the 0th index. I'm starting to think I'm writing some very repetitive code, but that could be on you guys to try to correct. So now I think we're good to run this. Okay, so list object has no attribute data. I messed it up again. All right, so this is the first one in the list, or we can do -1 because it'll end up being the same element. All right, now we can run this. So now all of them do go to the first. So okay, the reason for that is because currently we keep adding collision handlers between 1 and 102. So we keep adding the same collision handler over and over. And so every ball has the same collision identifier. What we need to do is have a different identifier for each ball. So I think the best way of doing that is we do have a list of balls. And I think it would make sense just to have the collision identifier just be the index that the ball has. So we have to change each ball's collision number. So to do that, we'll pass it in as an argument to the ball constructor. And so we have to go up to the ball.init method. And just like we did in the wall class where we brought the collision number in, I think we should do the same for the ball class. And again, I love copy and paste. I think it is the best thing ever invented. So I'm going to copy and paste. And over here in the first ball, we set the collision type to be 0. So for all of these first handlers, they should all refer to 0. And it would make more sense to put them all in the same place. I'll let you guys figure out how to redesign the code. And then when we add balls, we need to also have the new collision handlers be that index, be the new identifiers that we want to use. So instead of 1, we actually have a variable that's storing our index. So we can just say index. Index. And lastly, index. Okay, so let's run this. And of course, we still have the same problem because today is the day of errors. So I think the reason we still have this problem is because we didn't give each ball the collision handler index that we want to give it every time. Length of balls here. So let's try to understand why this would be the length of balls. So imagine you are pressing spacebar for the first time and we're looking at the second ball edition. So at that point, length of balls will be 1, and we want the new ball to have that index of 1. Now let's try this. And that is more like the behavior that we're looking for. Perfect. Wow, this is starting to become kind of hard. And as you can see, all the balls are colliding with each other, which is great. And all the physics is done behind the scenes with Pymunk. Now we can cross off our list many balls. Now, the last thing we want to do is have the walls cave in. And this can also be a little tricky. So let's understand what needs to happen to have the walls cave in, I'd say every time the ball scores. How are the walls generated? Well, we have these wall instances that we name wall left, wall right, wall top, wall bottom. And they're made from the left top, left bottom, etc. global variables that we've defined all the way up here. We want to change these within the game loop or within the game function. We should generate a function that says, I guess, cave in. And I guess we can make it over here, define cave in. And I'll say global, the left, right, top, bottom, left, minus equals, I don't know, every time we want to cave in, let's change it by 5 pixels. Right, minus equals 5, top, minus equals 5. And again, this will keep the screen symmetric. Bottom, minus equals 5. Great. So we want to run this every time a player scores, and luckily we have our functions for that. So we can say cave in, cave, that's not how you spell cave at all. Oh, and if we want to cave in, we actually want the left wall to be increasing by 5 and the top wall to be increasing by 5. So that'll allow all 4 walls to cave towards the center. So if I run this, is this going to be enough to cave the walls closer together? Well, let's try it. And everything else seems to be caving in, but not the walls. So let's understand why. The wall instances in wall left, wall right, wall top, wall bottom have not changed. And so their position values have not changed. So we're going to need to rewrite these within cave in. And for these to work in the scope of the game function, but not necessarily the global scope, we can use the keyword non-local, which is only available in Python 3, by the way. And we'll non-local all of these. Right? Ball, top, ball, bottom. Now there is one more complication here. Every time we make a new instance of the wall class, in the init method for the wall class, we're going to be adding the shape to the space, but we're not going to be removing the previous shape from the space. So we have to remove the previous shape from the space before we can create these new wall classes. So let's go ahead and do that. I can say space dot remove wall left dot shape, and we'll have to do that for all 4 walls. Right, top, and bottom. So now let's try this. And the walls are certainly caving in. The players are not, and we probably should have a minimum value that we can allow the walls to cave into. But let's figure out the players first. So within the cave in function, we can redefine the player position. So I'll say player1.body.position is equal to a new left value, right? So player 1 is on the left, and we want to keep it at left plus, what did we have player 1 start before? 15. So left plus 15. And the y value should stay the same as it was previously, body.position of 1, sorry, for the y value. And we want to do the same thing for player 2. And this one was right minus 15, player 2, player 2. Let's run this. And now the players are shrinking along with the screen. Lastly, let's try to give it a minimum shrinkage. And I think first of all, before we do that, I think we should probably slow down the shrinkage because that's kind of quick. And I like 2. Now let's see what that looks like. Yeah, it's a little slower. And if we want to minimize the shrinkage, let's say so we can just take one of these values and compare it to its original value because they're all moving by the same amount. So left starts off at 25. So I think if we stop the shrinkage when left is greater than or equal to, so if left is less than or equal to 75, then we can continue to shrink. So let's try this. So screen continues to shrink, and then it stops shrinking at this point. And as of now, we have our thumbnail. So this is definitely a little chaotic, but there are a lot of other things you can do with this game of Pong, and I'll let you guys continue to explore. But this ends this series for the Pong games. If you have any questions though, please leave it in the comments and I'll be happy to get back to you.